Hi guys. So today we are going to do the last section in our circles chapter, and that is section 12.6, and it is angle measures and segment lengths. Okay, this is in your volume 2 and it is on page 848. Okay, so let's start. So the first theorem that they have on page 848 is the measure, it's theorem 86. Remember what's a theorem? A theorem is something, it's a truth, it's a fact in math which has been proved by scientists. It has been accepted that it's always going to be true. So you don't need to go and explain why it's true or prove that it is true. You just take it at face value and use it. So the theorem 86, what it says is the measure of an angle formed by two lines that intersect inside a circle is half the sum of the measures of the intercepted arcs. So let's read this problem again. We have a circle with a center. There are two lines which intersect and the point of intersection is inside the circle. So this is one line and the other line is maybe here. Okay, so these are my two lines which are intersecting. They are intersecting in point, let's see, where did it go? They are intersecting here in point P. So what I need to prove here is this angle is the angle formed inside the circle. This is going to be half of the intercepted arc. Now which arc is intercepted by this angle? It is this portion. So let's call it A. This angle, again, these two angles are congruent because they are vertical angles, right? They are formed by two intersecting lines. So this angle is equal to this angle and this angle is intercepting what arc? This arc here. Now can I call, because this is A and because the intercepting, the angle is there congruent, can I say this is A, this is A? No, I cannot say that. Okay, when is that true? That is true when I have two lines which intersect at the center. So if this is my center, in this case, if this is angle A, I know the measure of the intercepted arc is also A. That is because the vertex lies on the central. So this is a central angle. Only the arc intercepted by the central angle, the measure of the arc will be equal to the angle. Now this angle, is this a central angle? This is not a central angle because the vertex of this angle is not on the center. This is the center here, O. The vertex is not on the center. So I cannot say that since the measure of the arc is A, the measure of the central angle is also A. I cannot say that. Whereas here, because it's a central angle, the central angle is equal to the arc. Now these are vertically opposite angles. So if this is A, I know this is also A. Now this is the central angle for this arc. So the measure is again going to be A. So the measure of the intercepted arcs is the same because the angles are the same and they are central angles and they intersect the measure. The measure of the arc is the same as the central angle. But I cannot say that this arc is A, so I cannot say this angle is A. It's going to be something else. So what I need to prove here is measure angle. Now what's this angle? This is P. Let's give it some names. I already used A and B. Let me not use A and B. Okay, A, B, C and D. These are the points. Let's call this X and let's call this Y. Okay. So now what I need to prove here is, can I just say my measure angle P? There are four angles here. So I have to specify. Measure angle APD is what? Half. What does it say? Measure of the angle formed by two lines that intersect inside the circle is half the sum of the measures of the intercepted arcs. So this is going to be half measure arc AD. Now there are four arcs here. You have to be careful which arc. It's the angle intercepted by this, the arc intercepted by this angle and its vertical angle. So this arc. Okay. So this and this, the sum, this angle is going to be half of the sum of these. Okay. So now let's prove this. So what I need to prove is half of x plus y. I need to prove this. Okay. So let's prove it once. So once we know it is true, we can use this as a property. So what can I say here? Let me form this angle here. So if I form this angle, what do I know? Going back to our properties, this angle here, okay, this is not equal to this. This is just some random angle. What is this angle? This is the inscribed angle for this arc, right? We are talking about arc BC. So what else do I know about arc BC? This is the inscribed angle because its vertex lies on the circle. This angle, the vertex does not lie on the circle, so it's not inscribed. It does not lie on the center, so it's not central. It's just a random angle about whose measurement we don't know anything. So now this is my inscribed angle. So what do I know about the inscribed angle? This is our proof now. So this, I can just call this measure angle D because there is just one angle there. So measure angle D I know is half of what? This measure arc BC. Right? Now let's look at this angle. This angle is again an inscribed angle because its vertex lies on the circle. So this is the arc. It should not be equal, right? I don't know whether they are equal, so it should be something else. Okay, let me give it a new symbol. Okay, this angle here, this is not, typically we don't use this. Let's just call this angle here is going to be, is intercepting this arc. Again, it's an inscribed angle because its vertex lies on the center. So this angle will be half of this arc. Let me just call it measure angle C is half the measure of arc AD. Okay. So now what do I know? I want to add these two arcs, right? BC and AD. So what do I know about the addition? These are here, right? What's the relation between CD and our required angle? Now remember, there is a very important property. I'm not sure if you have seen this before. If there is a triangle, okay, let's call it A, B and C. These are the measures of the angles. And this is an exterior angle. What's an exterior angle? Exterior angle is an angle which is at a straight line, linear pair with any of the interior angles. So this here is not an exterior angle. The exterior angle for A will be this. It has to form a straight line. So here the D is the exterior angle. Now what do I know? What I know about this triangle is, I know A plus B plus C. They are the sum of the measures of the angle. I know it is 180. One more thing I know there is C plus D is also 180. Right? Because they are linear pair. Since they are both equal to each other, I can say they are equal to each other. A plus B plus C is equal to 180. They are both equal to 180. So they are both equal to each other. So if I subtract C from both sides, what I'm left with is A plus B equals D. This is a very important theorem. It's an exterior angle theorem. What does it say? It says if there is an exterior angle, that exterior angle will be the sum of the remote interior. Now this is also an interior angle, right? But this angle is related to this exterior angle. So I'm not going to consider this. I'm going to consider the other two angles which are not, the other two interior angles which are not related to this exterior. So this exterior angle will be this plus this. So we are going to use that theorem here, which is the exterior angle for these two angles. So this is the triangle. Okay. So if I say in triangle PDC, what do I know? I know that the measure of these two angles will equal the exterior angle for this angle. So this is my exterior angle because it's making a 180 degrees with one of the interior angles of the triangle. So the other two interior angles, their sum will be equal to this exterior angle. So what I have here is measure angle C plus measure angle D. The sum will be equal to this measure angle APD. Okay, so I'm going to use that here now. Measure angle APD is equal to measure angle C plus measure angle D. So measure angle APD is measure angle C plus measure angle D. But what is measure angle C? Just now we said it is half measure arc AD plus measure angle D. What is measure angle D? It is half measure arc BC. So if I take the greatest common factor, which is half outside, what am I left with? So what I have here is this angle here, which is formed by two intersecting lines. It's going to be half of the sum of the intercepted arcs, half of AB and BC. Got it? So we have this theorem now. We are just going to use it. We are not going to prove it every single time unless they ask you to prove it, right? Sometimes they may ask you to prove it. In that case, you have to show this proof. But other times, you can just use it. Like here, we just use the exterior angle, right? You don't have to show this proof. I just showed it to you just in case you were unaware of this. So let us see where it is used, what kind of problems, how we can solve them. So let me look at problem 1. It says, what is the value of each variable? This problem is not in your books. So I have a circle. This is the center. I have two intersecting lines, not necessarily at the center. This measurement is 46 and this is 90. They are asking me to find x. So I'm going to use this theorem. I know this is the angle formed by two intersecting lines. So x is going to be what? Half of the sum of the intercepted arcs. So it's going to be half of, this is one arc which is intercepted. The other one is this. Done. Half 136. So I get 68 degrees. Good. So this measure angle will be 68. See, 68 has nothing to do with the 90 and the 46. But it is half of the sum. So individually there is no relation between 68 and 90 or 68 and 46. What I know is 68 is half of the sum of these angles. Okay. Let me see if there's any other problem. Okay. So there is one more corollary to this. Corollary means there is a theorem and now there is something else which is related. Now we had two intersecting lines and those lines intersected inside the circle. Right? And then I know that this angle A will be half of B plus C. But what if those intersecting lines, they intersect outside the circle? Suppose I have something like this. So in this case, what happens is, so these are my lines, they are intersecting outside the circle. So in this case, the angle will be, let me just make sure. In this case, which are the two arcs which are intercepted? This is one arc and this is another arc. Always, because of the nature of the angle, this arc will be bigger, right? This is A and no, we called what? We called our angle A, right? So this was our angle A. One arc was B and one arc was C. In this case, measure your angle will be what? half of the bigger arc minus the smaller arc. You see the difference? Here also A is formed by two intersecting lines, but because the angle A is inside the circle, A is half of B plus C. But if that A happens to be outside the circle, then it's going to be subtraction. It's going to be this minus this. Okay? Let us look at one more problem. So, there is one more case here. This is case 1. Either it can intersect here or it can intersect outside. So, these two are called as secants. Remember what are secants? Secants are just lines which intersect the circle in 2 points. And the third case is, what if only one secant is formed? It is still intersecting outside, but one of them is a tangent, one of them is a tangent and the other one is a secant. Remember what's a tangent? It touches the circle only at one point. So in this case, again, I want to find the measure of my angle A, because these are the two lines. They are intersecting at A. They are intersecting here outside and they are forming angle A. So in this case, this is my arc. It's the bigger arc. So let's call this B. This is the measure of the smaller arc. It's A. So again, it's going to be A half of B minus C. There is one more fourth case, and in that case, both are tangents. So let me make it a little smaller. How do I fit this? Okay. No, I think I'll have to erase this. Okay. So if I have a circle and there are two lines which are intersecting and both the lines happen to be tangents. Okay, so they form an angle here. So this is my B, this is my C. Again, my A is going to be half of B minus C. So what we saw here was, there are 4 cases. The first case is, I have a circle and the lines intersect inside the circle. And the angle is formed here A. The two arcs are here, B and C. Only when it's inside, my A will be what? Half of B plus C. When it is intersecting outside, when those two lines intersect outside, these are the 3 cases that can happen. Either it can intersect outside such that both the lines are tangents to the circle, or both the lines are secants to the circle, or one of the line is a tangent, one of the line is a secant. In all 3 cases, the angle which is outside, that will still be half of the measure of the intercepted arcs, but now it will be the difference. So in these 3 cases, it's going to be major arc minus the minor arc, half of that. Only when it's inside, it's going to be the sum. So let's look at an example problem again. So be careful, you have to be careful and look at where the lines are intersecting, inside or outside, to decide whether it's a sum or a difference. So again, this problem is not in your books. They're giving us a circle and here they have a line which is a tangent and the other line is a secant. Okay, they're saying this is 20 degrees here. They are saying this is 95 degrees here, and they want us to find the measure of the smaller arc. So is it going to be a sum or a difference? Two lines are intersecting. They are intersecting outside the circle. Whenever it's outside, it's going to be a difference. So 20 is going to be what? Half of the difference of these two. 95 minus x. Remember, it's multiplication and this is parenthesis. When I'm solving, I don't do PEMDAS. I'm opening my present, right? So I'm going backwards. What I did first, I'm going to do last here. So instead of PEMDAS, I'm going to do SADMAP. First multiplication and then the parenthesis. So get rid of the half by multiplying it by 2, which means you multiply by 2 here. 2 divided by 2 is just 1. So I'm left with 95 minus x, 40. I'm going to add 95 to both sides. So I'm going to subtract 95 from both sides. So I get negative 55. I'm left with negative x. I don't want negative, I want positive. So I divide, I get x is 55 degrees. So this is 55. See, the difference is 40 and this is half of that. Good? Excuse me. So we did one kind of each where it's a sum and a difference. Look at the got it problems on page 849. I think you can do those. Okay, let's look at A2. That looks a little complex. I am on page 850. Page 850, I am doing the A2. Okay, so what it shows here is there is a circle. Please make sure you are doing these problems, the got it problems. That's your practice. So this is also a tangent here. They are saying the measure of this arc is x, the measure of this angle. Remember, I cannot find the measure of this portion between the line and the circle, because what's an angle? It has to have two lines, right? It cannot have one line and one circle. So I'm finding the measure of this angle, that this line and this line. So x, y, they are saying this is 50 degrees. And they are saying this arc is 160 degrees. Okay, so let's think, what are we going to do here? I think I can find x easily first, because these are the two lines. Okay, I'm not considered with this one at all. These are the two lines, they are intersecting outside. I don't care whether one is a tangent, one is a secant. When it is outside, this angle will be half of the difference. So if this is 50, 50 is half of the difference, outer arc minus inner arc. So when I do that, I bring the 2 here, I multiply both sides by this, I get 160 minus x. I bring 160 here, I get negative 60 equals negative x. So I get 60 equals x. So x is equal to 60 degrees. I want to find y. How will I find y? Y is going to be what? Now remember, this angle is formed by two intersecting lines, right? So I'm going to use this formula. But for this angle, am I going to use the difference formula? No. Which angle is this? The vertex of this angle lies on the center of the circle. So this is my angle here. The vertex lies on the center. So this is not this kind of an angle. This is an inscribed angle. And what do I know about inscribed angles? That this is just half of the arc intercepted. There is no sum or difference. Because anyway, there is only one arc which is intercepted, right? If it is outside, there are two arcs. Here anyway, it's just one arc. It's an inscribed angle. So because it's an inscribed angle, what I know is this angle y is half of the intercepted arc. Do I know the intercepted arc? Not yet. But I can find out, right? Because what is this? This is 160 and this is 60. So how much is this going to be? I know together all the arcs are going to be 360. So this is 360 minus 160 minus 60. So it's half of, this is 200 and this is 140. So I get 70 degrees. Let me check. Yes. Okay. Remember, this is an inscribed angle. The rule for this is different. It's just half. The inscribed angle, whether it's like this, in this case, if this is A, it's half of this. So this will be 2A. Okay. One more case of inscribed angle is if the angle happens to be, one is a secant and this is a tangent. In this case also, this angle is A, then this arc will be 2A. Good. Okay. Let's look at the next kind of problem. The next kind of problem is, okay. Now they are talking, I think it's similar to your got it problem. So what it says here is a satellite is in a geostationary orbit above the Earth's equator. It has a viewing angle of Earth formed by two tangents to the equator. So this is the Earth, as you know. It's not exactly a circle, but for the purpose of our math, we are going to consider it's a circle. So this is the circle. There is a satellite somewhere here and it is looking at the Earth. It can look as far as this portion of the Earth and it can look as far as this portion of the Earth. Okay. And this is called as the viewing angle. This they are saying is 17.5 degrees. The viewing angle, what is the measure of the arc of Earth that is viewed from the satellite? So now this is a tangent and they want, this is the arc which is viewed, right? X. So in this case, this is not an inscribed angle. The vertex is not on the circle. But since these are two intersecting lines which are intersecting outside, what do I know about their relationship? I know they form an angle which is half. Is it the sum or the difference? This point is outside the circle, so it's going to be a difference. So if this is y, it's half of y minus x, right? Now they didn't give us y. They have to give us at least one, right? We cannot solve an equation if there are two unknowns here. So we don't know y. But if you look carefully, what is the relation between x and y? Together they form the whole circle, right? So if this is x, what is this going to be? This is going to be 360 minus x. So this is x and 360 minus x. Together when I add 360 minus x plus x, I'm going to be left with 360. So instead of writing y, it would be better if I write, instead of y, I'm going to write 360 minus x. Now this is one place where students can make a mistake. They look at this minus x and they said, oh, I wrote minus x already. No, this 360 minus x is the y. And now this x, again you have to write it as minus x. So now I have an equation in just one variable and I can solve this. So this is half of 360. They are like variables. So I can just say negative 2x equals 17.5. So this I'll multiply both sides by 2. So here I'll get 35 equals 360 minus 2x. I'll bring the 360 here. So it will be negative 5, 4. So 325 equals negative 2x. Right? I divide this by both sides by negative 2. Right? So to give me x equals 162.5 degrees. Make sense? So here don't think, oh, I don't know y, I don't know x also, how do I find it? No, you know what y is. Y in terms of x is 360 minus x. Okay, so do the got it problems on page 850. Yeah, for problem 2, you can do the 3. Actually, you know what? Let me show you 3. It looks involved. So let me show you 3. I am doing A3. Okay, so A3, find the value of each variable. We have a circle with a center, and now this line is going through the center, so I know this is the diameter. This is